So now let me come to one topic, and I've been told that many of you have interest in this area, right? The systems engineering part, right? I'm going to cover all of this, and as I mentioned in the first presentation that I'd done, that we'll also see where exactly some of this overlap happens between PLM and systems engineering and the project management aspects, right? Many of you are already involved. Some of you are just beginning to take that journey, right? So for that, let me just start with a basic definition of that. Actually, there are many definitions that exist, right? So if you look at all the definitions, they are basically talking about two very important aspects. One is complex systems, right? And second thing is interdisciplinary approach, right? When we have so many people working on so many different components of a particular system, and each in its own right is very, very complicated, and then we have to manage that interface between the two subsystems. That's exactly where the challenge lies. And again, you are from this domain, you would also know that typically in those interfaces itself, we'll see the maximum failures, right? And that's exactly where the systems engineering approach comes in, right? But let's look at other factors also, right? Why exactly systems engineering is coming in and why is everybody talking about this, right? First and foremost, our own systems have become very, very complex. Now, if you look at the amount of software that we have compared to what we used to have about 10 years back, I mean, it is simply humongous. In fact, now we have reached a stage wherein we are not even surprised by looking at the amount of software that's there, right? We're not even surprised. It's like, it's a given thing. Second one is, I would also want you to think about how exactly you've been working now, how you are interacting with other sister labs, how it was about 10 years back versus how it is now. The amount of dependency, the amount of the collaboration that happens across all the labs and the manufacturing entities, again, it has increased quite a lot. Then the time pressures as well, right? We have seen in the past how some of the deadlines are missed, and typically deadlines are missed when we fail to consider some of the constraints of the product development, again, especially in that interface part, right? And so on and so forth. Quality, cost, all these factors, I mean, contribute and emphasize the need to have a systems engineering methodology in system development. There are many stats also. So one is the systems engineering as a concept. Second one is the tool that allows you to do systems engineering, right? And then we start talking about model-based systems engineering, a tool which will allow me to create those models and take a systems engineering approach is model-based systems engineering. There also many new concepts are coming in. Like for example, in my model-based systems engineering approach, can I also do some kind of what-if analysis? Can I also create some kind of variance? So if I start working on a new program or a new project, on day one itself, I have got 2-3 approaches that I can take. I have 2-3 options. I have alternates for every subsystem or alternate design for every subsystem that I can probably consider. Can I use some mechanism by which will help me to manage all these variants and later on help me to say that, okay, I'm going to go ahead with this configuration. All right. So that is called as product lighting engineering. In all of these, and by the way, in the pen drives that you're going to get after this session is over, you will have copies of these slides also. So you can look at the stats. And the stats are favoring that when we are using a tool for systems engineering, and when we are using, model-based product line engineering, how much percentage of success we have with regards to project completion on time. That's exactly why everybody is talking about systems engineering. That's exactly where the systems engineering initiative is going on in your organization. That's exactly where an organization like PTC, where we invest heavily in technology, is involved in also. All right? But let's look at it, because our approach, of course, is in line with systems engineering, but I personally feel that it is a much broader approach. For example, all of you would be aware about this V model, right? So requirements on the left, validations on the right. We start from systems level, we go to the subsystem level, then work at the component level where design and development takes place, and then the final validation will follow, again at all the three levels. But traditionally, it was limited to software, mechanical, and electronics components, which is again absolutely fine. But now think about it. Who's your design entity? Who is your consumer, right? Who's going to use the products and the systems that you're developing? And who's going to service that also? And hence, when I am doing a product development, I also have to take care of the manufacturability and serviceability. In fact, we had an event here about 7-8 months back, and Dr. Tamil Mani actually spoke about it, that one of the most important interface that exists is between the design entity and the manufacturing entity, right? So design for manufacturability, if we can include that as part of the systems engineering, everything is taken care of, right? And because of that, and precisely because of that, suddenly the whole scope becomes like this, because I'm not only looking at how I'm going to produce it, I'm also thinking about how I'm going to operate and finally support the system also. That's exactly our methodology comes in, where we are talking about providing a closed loop systems engineering approach, right? Now let's go ahead to the next concept. Because systems engineering is a methodology, right? And you've been doing this. I mean, you may not have been using a tool, may have been using a tool, but you may have been doing it on whiteboards and papers and things like that. So if we start talking about the other aspects, because when we are in this V model, right, and we are going from system level to the component level, suddenly from a product development aspect, we have to take care of many things. And hence, at every stage, I may be using different kinds of tool to finish that particular part of the product development process, right? Maybe I have to design the system architecture. Maybe I have to decompose all the requirements that I have, right? At a system level, subsystem level. Then for developing each and every component, maybe I'll use Creo for my mechanical design. Maybe I'll use Integrity for managing the software code that I'm writing. I may be using any IDE, for example, right? And I may be using any kind of PCB PCB design system for designing some of those things, right? And so on and so forth. Then the testing will follow. I have to ensure that everything is getting tested and all of that. But at any point in time, we're also talking about a traceability, right? I should be able to create this kind of traceability so that I can ensure that none of the requirements, none of the models that I'm defining as part of the planning stage is lost, right? Now the second aspect. At all these levels, system, subsystem, component, there are various kinds of processes which are running. Think about the amount of approvals that you have to take before something can be sent for proto development or for final production, right? Not only that, there's a lot of collaboration also that is taking place, right? Between your subsystems, managers who are there, sister labs, everybody is there. And hence, the change management process also becomes very important, because the amount of time that you spend in product development is very high. Change is inevitable. You have to ensure that you are able to collaborate with all these design people and take the right decision based on the information that is available to you, right? And then if we take it to the next level, wherein we are talking about generating various kinds of reports so that you can also monitor the health of the overall program. This is where the project management comes in. So essentially, you can actually see a very nice overlap of how the systems engineering as a methodology will help you to develop the systems under a project context in a PLM environment. And hence it leads to the term called as total lifecycle management, right? Where everything is working under a program or a project management umbrella, but at the same time, I'm taking care of all aspects of product development following the V model. All right? So I feel that of my 1 hour presentation that I'm going to do, this part is the most important part. Okay, so that's why I went really slow there. All right? But now, let's look at this part a little bit more. I mean, I'm going to elaborate this a little bit more. So when we start talking about product development, then these are some of the aspects that we have to take care of. things will start with model-based systems engineering, and we'll work with requirements, and this will go hand in hand. You will develop the models, you'll start working on the requirements, you'll develop the models further, you'll start decomposing the requirements even more, elaborating them even more. And finally, you're also going to write a lot of test cases to ensure that each and every requirement is getting tested, validated before you go to the next stage of the product development, right? Now, as part of your product development, when you start creating various deliverables, it can be software and it can be mechanical or electrical or electronics, all have to be managed properly. Because when I start talking about model, I would also want to know, okay, based on which model I'm doing my software development, based on which model am I actually doing my hardware development or the mechanical component development, and it is linked to which requirement, right? So all of this go hand in hand. And hence, you will also see that when these three concepts, the program management and total lifecycle management and things like that converge, you will also see many of these technologies coming together, right? And hence, it looks even more complicated. Because even if you ask the mechanical engineering group, they will talk about the amount of complex design and development that they have to take care of, amount of constraints that they have to work with. It's humongous. Same with electronics people, same with software people also, right? So each and every area becomes very, very sophisticated, right? And essentially speaking, when we are talking about systems engineering driven total lifecycle management, all these areas have to be taken care of. All the processes, standards have to be managed following what has been already established in the market, right? So that's exactly what we offer. Now, as I go ahead, I'm going to touch base upon each of these components at a very high level. Like I said, post lunch, we'll sit together. You ask me more questions about the MBSE tool, for example, or if you would want to ask me about the PLM tool, software data management tool, and things like that, please come and ask me, right? So we'll go in detail also. So first and foremost, let's talk about the model-based systems engineering, right? So people who are familiar with some of these tools, you will know that it's again, we try to have some kind of standardization in place by which if I am doing model-based systems engineering, the other person should be able to understand and carry the work forward. So now, we are not only talking about simply making the models for model-based systems engineering, we are talking about a collaborative way of doing model-based systems engineering. We are taking it to the next level, right? And now you think about your own organization. Typically, what we have seen in the last 2-3 years is that you may have systems engineering initiative, a 5-member team would have been formed, but honestly speaking, at the project manager level, at the program manager level, suddenly you need to have participation from everybody, because as a software, as a systems engineering person, you will still need feedback from the mechanical design department and the electronics design department about what are the other things that we have to take care of, what are the use cases that we have to specify, what are the requirements that we have to take care of. And hence, it is going to be collaborative, period, right? So, if you go further ahead, let's understand few more concepts. One of them is how exactly some of these models are created, right? So, the image that you are seeing over here, even though the text is not clear, it's absolutely fine. These are all standardized. The way we are defining the interfaces are also standardized also, right? And then how exactly we can specify some of the dependencies also becomes very important. How they will be linked becomes very, very important, right? And last but not the least, how exactly do we ensure that all these are standardized? So for model-based systems engineering, just to let you know, you can go to a website called as omg.org, omg.org. So OMG stands for Object Management Group. Now, this group is very, very important for model-based systems engineering, because if I say that I'm going to use a block like this to define my first primary block, or I'm going to use an icon like this to define XYZ kind of relationship, that standard has to come from somebody, and that body is OMG. Now, we are little fortunate that few people from PTC are part of the board members of OMG, and hence how that helps us, as and when new standards come about, and every 2-3 years they are releasing new versions of the standards, by default we are able to adopt it quickly in our technology also. So that's how it works for us, right? And so on and so forth, right? Whether it's SysML, whether it's UML, whether it's following some of the standards, right? Like for example, the DO standards and things like that. everything gets incorporated. All right. So this is also important about, when you start talking about systems engineering, and as you are taking that journey, as you're taking that learning path, it is also important to ensure that you're taking based on the standards which are available in the market, right? Which are defined in the market. The next one is the complete flow. Now, don't really want to stress on this, but everything starts from the planning phase itself, right? And then we start defining the context also, as basic as this. Now, if I'm creating a model for servicing of, or let's say as basic as removal of a motherboard from a system, right? As basic as that. Now, if I'm defining that, suddenly the interface is not only about two electronic systems or mechanical systems talking to each other, right? It is also about the person who's going to do it, right? Somebody has to remove it. Suddenly we are talking about an actor getting involved. So we are also defining what is called as a context, right? So we are defining it under a context where multiple use cases will be defined. Same way, we'll start elaborating the requirements more and more as we go ahead, right? We'll also go ahead and define all these use cases around the interfaces which are there. Then we will also create what is called as a sequence diagram. Now, why is the sequence diagram important? So now if let's say I'm an actor and I have to service a particular system, I have to open something, I have to take something out, and I have to keep something away. Now, if I'm going to do it for a mission critical thing, I also have to have some mechanism by which I can simulate the whole model that I'm developing. Now, I can only simulate it as long as I can create that sequence, right? So I create a sequence diagram, and then I can go ahead and complete the design architecture. I can also create various kinds of relationships with the physical design that I'm doing, right? The actual design work that I'm doing, right? So typically, when all of this is ready, then I will actually go ahead and create and validate each one of those things, right? Use cases, requirements, and finally, of course, the model itself. Now, let's have a quick glimpse at how does a MBSE tool look like, right? Now, in this case, I want you to think about a couple of things. One is everything is based on the standards, but everything is managed in a central repository, in a database, right? That's very, very unique. So what it means is that you can create multiple models, right? Inside that database, anybody can log into that system, get access to the model which is there, right? The overall MBSE tool would look something like this, right? You can keep looking at the video itself, right? Wherein, let's say I have to create a block diagram, or maybe I have to create an internal block diagram as I start and I create, as I decompose all these models as well, right? So you can actually create it by click of a button, and as and when you are creating it, each one of those gets, the definition of each one of those gets, created inside the database itself, right? And then you can define the block definition diagram. And let's say somebody else starts using it. So it's available for reuse as well. So for a similar program, I can actually make use of a subsystem model that has been already created. So I'm dragging and dropping. And in case I make some changes, if another person makes the changes, the same thing will get started reflecting for the model that I had created for a different system, right? So that's where we are talking about usability aspects also. Of course, needless to say, everything has to be access driven. So if I don't have access, I will not be able to do anything, okay? So the bottom line is, whatever work that I do as part of this, everything should be consistent, right? So something like that. Next one is how exactly we can cross across all the disciplines, right? Now, for example, in this case, we are looking at the truck model, and if I start working with the other modules, like I was saying, I will have to define the requirements and the use cases. And this can be a multiple member activity, right? We call it as stories as well, right? So typically use cases will be created under the context of a story, and then you will define. So if a driver has to operate the truck, these are the things that he has to take care of: loading, unloading, drive, sleep, repair, and all those aspects, right? So suddenly under that context, under that story, I'm going to create multiple use cases also, right? So I hope you get the sense, right? I went very, very quick on this. Just to summarize, a tool based on standards, based on, there's a database which is running in the backend. and I emphasized on the term called as collaborative MBSC, right? So everybody can work on it in a access controlled environment so that everything is taken care of, right? All right. Now let's go to the next level. So I was right there at the top to start with, right? I mean, the system architecture is going on. Now, when I start working on the requirements or when I start working on the software part also, the application lifecycle management, which does software development lifecycle management, will come into the play, right? So let's look at this and let's understand this. But before that, a problem. Now the problem is like this. So I was, this is my 14th year in PTC. First 7 years I was working in the R&D department of PTC, and PTC is a pure software company, right? Now, in a system development environment where there are a lot of mechanical engineers and electronics engineers and all these senior scientists which are there, sometimes what happens is that the software group actually looks like a black hole, because it's very difficult to understand when you say that my code is stable and code is not stable, right? Even a critical bug is one single bug can become a huge problem, but a declining trend of the number of bugs may give an indication that the code is fairly stable. Okay, again, the definition of fairly will vary. A and D is totally different, right? So, but what happens is that people don't get access to some of these things. That is visibility to release readiness. Everything is based on verbal updates. There's a lot of software changes happen. That's why it's very different from a PLM environment. Everything is managed under the context of a change package, under a change process. Then of course the variants which are increasing, you're working on Mark 1, Mark 2, simultaneous developments are taking place. How can I branch all of them? How can I manage them properly together? It becomes a problem. And finally the collaboration part, because now we are not only talking about collaboration within the software group, but also working with the systems team, right? I mean the mechanical team and things like that, because at the end of the day, the software is going to sit in some embedded system, which is going to sit in some mechanical housing in a system, right? So that's where the complexity comes in. But let's take a step back. Let's look at the pure software world itself, right? So in this case, you will see that in a complete life cycle, there are so many aspects that we're taking care of. Designing and the requirements, the tests, the defects that are coming in, and of course the code that I'm writing. What we have seen is, and it's not specific to DRDO or aerospace and defense, it is there everywhere. In the private world also we see the same thing. People have got tools, and these tools may talk to each other, may not talk to each other, but not every aspect of the design is kind of connected, right? And the bigger problem is the output of each one of those is in different format. And hence what happens is that the same problem. I cannot reuse the information. Things are disconnected. I may send an email, but again, that's where the connectivity will end. And hence it leads to more problem. That is why we need a system, one single system that can take care of all the aspects of application development or the software development. It should also be backed by some of the core capabilities like traceability, workflow, enabling an audit history, who does what, and based on the compliance standards that you have to follow, I also should be able to understand that all the requirements are specified in that particular format and all the validations are happening based on that methodology itself. Okay? So I can see that many of you are trying to take notes, but this slide will be made available to you. We have pen drives for each one of you, so don't forget to take those pen drives also. Now let's go to the next level also, because again, we are not talking about a software program, right? We are talking about system development. And the traceability becomes very, very important. So from the requirements model to the functional model that we are developing, to the complete structural design that we are going to make, right? And the variants that we are going to add, we should be able to specify all kinds of relationship. And I should be able to run the reports that can tell me, for example, what are the test cases that are validating a particular requirement, right? So this is one screenshot of the tool called as integrity, where I have a requirement and there are three test cases which are kind of supposed to validate that particular requirement. The next one is, in the same requirement context, I should be able to also link my software code. So I now, in the requirement, I have a Java code which is linked to it. So I can also kind of associate a project also to that. You can also have project files being linked to each and every requirement, right? So you're talking about those kind of traceability. Next thing that will become very important, especially from the PMO group, will be these kinds of reports, which would be how many requirements are there which do not have a test case, right? I should be having some kind of report. So the area that you're seeing in red in the pie chart, it becomes very, very important. That should be 0. Not only that, typically, I will be doing my test case execution. There's a quality team that will be doing that, and they will say that, okay, I had about 500 odd test cases and 400 are passing and 100 are failing, right? But think from a systems perspective now. How can I say, so my system has got so many subsystems. Based on those test cases, is it possible for me to say that which subsystem is stable and not stable? Of course, we do bifurcation based on the test cases, but imagine having a mechanism that gives me the test case execution result, of course, based on the test cases that I'm passing, but also telling me that for a requirement which had about 3 odd test cases, there are 2 test cases which are passing, and hence the pass percentage of the requirement is 67%. That's what we mean by traceability. All right. So let's go ahead now. So I'm again going a little fast. So we started with the model-based systems engineering. I have touched at a very high level about how it is done. What I've not spoken about is how the software code is managed, how we can do branching, how we can manage the complete project history, how I can create a baseline, how I can do certain comparison, and of course, how exactly some of these things are linked. I've not spoken about that. But rest assured, this tool is being used at so many different places that this is a very, very sophisticated tool, right? Including PTC R&D uses that. So in case you want to see how PTC R&D does it, and our products are all software, right? Right from Creo is a software, and Windchill is a software. So everything happens in that only. So we can again take you through that journey as well. Now let's talk about the PLM part of this also, right? Because end of the day, PLM becomes that backbone that is going to connect everything, right? PLM is going to be that system which is going to kind of have a link of what is the hardware, what is the electronics, and what's the software code which is linked to that, right? And I'm kind of going ahead with the assumption that most of you have been exposed to PLM as a concept, right? End of the day, we are talking about one single system that can become a single source of truth for managing all the product artifacts, system artifacts, and managing all the processes and providing the right kind of report. I also talk about this aspect about, PLM is actually that kind of, again, if you look at it as a methodology, it's that methodology that connects people to processes to technology. So we will talk about how exactly some of the design data, the mechanical design data would come into the PLM system. So MCAD data management becomes important. How exactly all the design and development are managed under project context. How exactly we can create manufacturing artifacts like manufacturing instructions and manufacturing bombs and so on and so forth. How exactly I can create various configuration. In your case, the test configuration is different from the design configuration. The manufacturing bomb would obviously be very different. And there is the transfer of technology that happens between, for example, DRDL, ASL with BDL. That's a huge process in itself. Same way, the way you're working with your manufacturing entities. I mean, there's a huge scope of handshake, right? Where we can use technology to bridge that gap together, right? So this becomes very, very important. And then as we go ahead, some of the other sophisticated areas like product structure management, managing your own supplier data, right? Because you're working with a lot of other design private entities also. And finally, including quality also as part of your product development process, both for pre-manufacturing and for post-manufacturing, right? So PLM essentially takes care of all of this, right? Just to reiterate, I had shown one leadership graph also where it showed PTC as number 1 in PLM. This is exactly the reason why we are number 1, right? Again, in terms of the full breadth of solution that we offer over here. But going forward, let me show you a quick UI. Some of you already have this, so you would have seen this. So just bear with me for a couple of minutes. It's a video with audio, so you will get to see this. Now it will talk about cloud per se, that is deployed on cloud, but it's the exact same system, whether it's on-premise or whether it's on cloud, right? So let's have a look at this video now.
The PTC PLM Cloud provides an instantly available central repository for product content. Managed by PTC in a secure cloud infrastructure, the PTC PLM Cloud manages all forms of information generated during product development, from customer requirements to CAD data to bills of material. With seamless integration to common CAD tools like PTC Creo Parametric, it's simple to manage new designs or update existing ones. An embedded browser provides quick and easy access to all cloud-managed information. Simply right mouse click on any item, select Check In, and it's now securely stored in the cloud. To quickly find items, there is a search toolbar always available in the top right corner. Enter the search term and a window slides out with the search results. With one mouse click, you get all of the information about a particular item, including where it was used and what objects are related to it. PTC CreoView Lite, PTC's visualization tool, is also included to distribute information to people who do not have design tools on their own computer, but need to see and interrogate product models. Reviewing a particular design, making comments or markups, and taking measurements can all be done without disturbing the original design file. It's also easy to manage documents from within the Microsoft Windows environment. In this example, we're actually navigating through cloud-based folders inside PTC Windchill, even though we're in Windows. To add a document, simply drag and drop it into the folder. Another feature is the ability to easily manage the entire approval process. Users assigned with approval authority can look at the instructions, give their comments, and then ultimately decide whether they want to approve or reject the item. PTC PLM Cloud empowers organizations of all sizes to effectively organize and manage their product content without incurring high IT overhead and infrastructure costs. And because it's PTC Windchill, production-proven PLM software, it not only meets your requirements today, but provides a platform to meet your future needs. PTC PLM Cloud, instant production-ready PLM.
Yep. So the data management, the change process, right? So everything is included in that Windchill backbone, and that's how it looks like, the UI that you saw. But PLM systems in general traditionally have had a problem. And the problem is like this. When we talk about PLM, which is Product Lifecycle Management, it's not a tool that is meant to be used by the design group. It is a tool that has to be used by the manufacturing team, the service group, and everybody. Now the design group, what happens is that they are always working and hitting the server. They're always working on the system, right? So they are very much used to the PLM environment, the options that it throws, and the UI, the way it looks like, right? So they're very comfortable working with the PLM system. But if we extend that further, manufacturing team, who will probably use it, probably 20% of the time, more than 80% of the time, they'll find it difficult because again, there's a learning curve that's involved. And hence, there is a need to find out if there is a way by which we can simplify the whole thing. Now, let's look at it like this. By manufacturing, I also mean that you should also look at, for example, the quality team, right? So the quality team will need design data for them to plan their quality activities, right, and do tests around that. And by the way, they come to you physically and they get the information and then they try to do it. Now imagine having a very, very simple UI wherein if somebody wants to view the document, he clicks on this, just gives the document number and the document opens just like that and he's able to access the information. Same way, if he wants to work with drawings, he can do that. If he wants to see the Creo view, the design data, how the 3D data, how it looks like, he should be able to see and he should be able to work on that. Now the next level that happens is that for people to take decisions, right? Again, there are design constraints that you have to consider. You also have to consider manufacturing constraints. Now, at a lot of places, you will see that there's an ERP system in place where the manufacturing side of things or the inventory side of things is managed properly. So the information, the physical side of it is managed in an ERP system or an MES system, whereas the design information is managed in a PLM system. Hence, we need a mechanism by which we can quickly develop an application where I can see information from both the sides. So on the left-hand side, I'm seeing information coming from the PLM world, right? I know the texts are not visible, but these are all the parts which are there in the design system. And on the right-hand side, you have the stock information from an ERP system. So even though integration is possible and we have done it at a lot of places, now imagine if I have to take or approve a change request, I can do that quickly because I get visibility to both the informations, right? But again, the beauty of this is not what we are presenting over here, right? I mean, how exactly we are putting down the UI. The beauty of this is how quickly something like this can be created. And if you remember in the first part of my session, I was talking about a platform that can connect to all of this. I said IoT is something that we have not discussed. That IoT is being used as a middleware to connect a lot of business systems. That platform is being used as a middleware to connect to a lot of business systems. This is developed on that platform by our own customers. So they are able to do it themselves, get the information which is relevant to them, and then leverage that for making informed decisions. All right. So that was about the technology part. Now let me also go back and talk about a methodology part. Now this concept, for example, which is called as a part-centric approach, has been there for some time. I mean, it's been there actually. Now traditionally what happens is, now if you look at the definition of your own product, your product is not represented by the 3D model or the drawing that you have created. There are so many information that goes along with that. Like for example, maybe the model diagram, the function diagram, the specification, the requirements, all these, the sensors and the electronic system that has to sit inside that, all of this are part of your design data definition. However, what happens is, and it is still continuing, it will take some time, I mean people are still taking that journey, is that drawing is the one that is mother of all information, right? So inside the drawing, I'm going to specify a lot of information. Like for example, the BOM information, the part number information, what's the quantity, what are the processes required, and the revision information. Everything is inside that. Now, when you work with your design team and let's say that design has to be released, imagine how much time he will have to spend to ensure that all these informations are captured properly before it can be sent to the next stage, right? Be it quality system or be it the manufacturing entity, right? So a typical dependency would look like this, right? Wherein unless all these are specified, he is not willing to send the information to the next level of people. There also, on the other side, there are different kind of stakeholders and they're looking for specific information. Like for example, some people would be only interested in the BOM information. Some people, the quality people, for example, they'll be interested in critical dimensions. Some people, the procurement group, would be interested in the material specification and things like that. And hence, if my downstream users are different, why do I have to create one single document that has all this information, right? That's exactly where we talk about that transition process where one can move from a drawing-centric approach to a part-centric approach where the BOM item becomes the backbone of the information. And then we link all the information, whether it is the design specification, the CAD information, whether it is the critical dimension information, some of the tests that has to be done, everything will be captured in the part information, right? And essentially, the whole composition process would look like this, wherein each of these will be captured separately. They will have their own cycle of review and it will go to the right stakeholder, okay? So that's exactly the part-centric approach comes in, right? Now, why am I talking about this is because, oh, by the way, this is not it's there in every PLM tool right now, right? And it is there for a reason, so that it can improve your overall efficiency in terms of how you're developing some of this information. Why I'm deliberately stressing upon this is, as you take the PLM journey, see that if you can look at this, because it's a major cultural change right now, right? Wherein, your information would start looking like this. All the informations are together and it is managed by one single part, like the BOM part, right? So this is exactly where this is exactly how the part-centric approach will look like. Now what I'm going to do is, I'm going to talk about the next step, which is when I enable a part-centric approach, suddenly I'm able to take care of other aspects also, as basic as taking care of all kinds of traceability. Because remember what I said, I was saying that when we create the model and when we create the requirement, it's not only for the software, it's for the mechanical components and the electronic components also, right? Wherein we can take care of some of these things also. Now I'm going to show you a video about how some of these traceability can be created. I don't expect you to remember that video about the sequence that was followed, but what I definitely want you to remember is how exactly that part information can be linked to the model, can be linked to the requirements also. So let's get started. Again, we are making use of something called as Managed Traces app within our platform, and it would typically look like this. So on the left hand side, I have the BOM, and I invoked an action that allows me to create those kind of traceability. So when I click on it, on the left hand side, I have all the requirements which are there. Again, it's very, very small, so I'll go a little fast also. And on the right hand side, I have the design BOM that has been created over here, right? So all the visualization is automatically coming over here. Now what we are going to do is, on the left hand side, we are creating the requirements document from which my design and development has happened, right? So I will search that information, I select the particular requirement, I'll click on OK, the whole document has come over here. But one of the requirements has led me to development of that design. So I have selected those two items and I'm going to now create the traces, right? So I've created the traces. Now when I go back to the UI, I mean, of course, I can validate all this information over here. You can click and, there was a 2-pane there. When I go back to the UI, suddenly, if I click on that part, there is an icon which is there. It also tells me that, okay, there is some traceability and there's a traceability link called a satisfy link, which has been created. The next level of traceability will be with the models that I'm creating as part of the MBSE solution, model-based systems engineering tool, right? Again, the same aspect. So I have the BOM on the right side. Now I'm retrieving the models that I've created, which will have a list of all the models coming from that particular database that we spoke about earlier. And then I'm going to select the model, which is going to be linked to that, right? So, and I'm going to specify a particular kind of traceability also, right? So now a model also has a traceability with the design document or design part that I've created. So I can do the same thing. I can validate also how it exists. On the left pane, I'm seeing the models. On the right side, the traced items also, okay? So from this UI itself, I have the flexibility of going anywhere. I can go ahead and double click on the model. It opens up in my MBSE environment. I can also open it in browsers to understand, okay, what kind of information is linked. Of course, I'm already in the PLM solution, so I can always see the BOM information. Let's look at the traceability link again. And suddenly, I have got two kinds of links which have been created, right? So that's exactly how it works. So typically with a model, I'll create a link called as an implement link. Whereas for the other one, I will create a different kind of link. So it would vary based on my definition. And from there itself, I can go into my requirement client and I can see the part which is linked to that. So we saw basically 3 environments here. One is the PLM environment, one is the requirements management environment, and one is the, of course, the MBSE environment where all these things are linked. Now, if I make a modification, right? If I were to make a modification in any one of the requirements, I would want it to get highlighted in some manner. So in this case, you will start seeing that some modifications will be done and a suspect link will start coming over here. So this red part that you saw is called as a suspect link, because I will have to ensure that whenever the requirements are getting modified, I'm notifying the downstream people that there's a change, and hence everything has to work fine, right? So just to take a step back, right? Because this was my last piece of my presentation. So we started with the whole concept of systems engineering methodology, how it works with PLM, how it works with in a project management context, and how all of that leads to a total life cycle management, right? We also had a look at, glimpses at the software, how some of these models that can be created, how some of the standards are already part of the system, how we can also have the design data managed, right? And all of them linked together through what we call as traceability, right? So that's the end-to-end spectrum, okay? And believe me when I say this, it's not easy to take all of them together, or it's not easy to start one off and then, there's no right way of going about it. That's why we at PTC, and that's exactly what my role is also in PTC, work with our customers to create what is called as a roadmap. How we can ensure that all the different users of different tools can focus on their work itself, but at the same time, for the people at the system level, we can have all the information put together so that their activities becomes very, very easy without any problem, right? So you ask this question to your program director, he'll be very happy that how end-to-end information can be managed, all right? So that's the end of my presentation, all right? I'm sure that you'll have many more questions. We can do it now also, because now we are going to have a 15-minute tea break. The tea will be served. And feel free to ask me questions. And beyond 2 o'clock also I'm available. I'm myself based out of Bangalore, so I can stretch my evening also. There is absolutely no problem.